Good morning, students. Today we will have another discussion about wave. Based on the amplitude, there are two types of wave, traveling wave and stationary wave. In this video, our discussion will be only about traveling wave. Traveling wave is a wave in which the particles of the medium move progressively in the direction of wave propagation. We can see here the wave pattern that is seen traveling through a medium. From time to time, we can see that the wave travels. The black one, and then the red, the blue, and the green. We can see that it seems to travel along x-axis. A crest is seen to move or progress across a medium. That is what we called a traveling wave. Now I will derive the equation of the displacement of a traveling wave. In this figure, we have point O. It is oscillated up and down so that wave is formed. The wave is traveling to the right along x-axis and it travels with velocity v and it reaches point P, which is at a distance x from point O. The displacement of wave at point O can be written as y0 equals a times the sine of omega times t0. Omega is equal to 2 pi f or 2 pi over period, and t0 is the time point O has oscillated. Remember the equation of a particle undergoing oscillation or simple harmonic motion. The wave needs time to travel from point O to point P, and the time needed to travel will be equal to x divided by the velocity v. So, when point O has oscillated for t0 second, this should be t0, then the time point P has oscillated will be t0 minus x over v. Remember that x over v is the time needed so that the wave will be able to reach P from point O. For example, when point O has oscillated for 5 seconds and it takes 2 seconds from point O to point P, then the time point P has oscillated will be 5 minus 2 seconds or 3 seconds. So we can write down the equation of displacement of point P as yp equals a times the sine of omega times tp, or equals to a times the sine of omega times Tp is T0 To minus x over V. So it will be equal to A times the sine of omega times T0 minus K times xp. This K is called the wave number in the unit of meter to the power of minus 1, and K is equal to 2 pi over lambda, or it is equal to omega over V. So generally, the equation of the displacement of a point at distance x from O can be written down as y equals plus minus a times the sine of omega t0 plus minus kx plus theta 0. A is the amplitude, and this plus minus sign shows us the direction of the initial oscillation of the wave. If it oscillates upwards first, then it will be given positive sign. If it is oscillating downwards first, then it should be given negative sign. And omega is the angular velocity. As we mentioned before, it is equal to 2 pi f or 2 pi over period. And k is the wave number. As we mentioned before, it is equal to 2 pi over lambda or omega over v. this t0 is the time the source of oscillation has oscillated, in this case point O. So this quantities in brackets all shows us the phase angle in radian, and theta 0 is the initial phase angle, also in radian. And I want to remind you that phi is equal to theta over 2 pi. It is called the phase with no unit. And delta phi is the phase difference, also no unit. Delta theta is the phase angle difference in radian. And delta phi is equal to x over lambda, or delta t over period. And delta theta is, of course, delta phi multiplied by 2 pi. It is equal to kx. This kx is equal to the delta theta. And the oscillation speed of a traveling wave, as we discussed before, that oscillation speed is the first derivation of the displacement to time. So phi at point P is dy dt, or it is equal to plus minus a times omega times, this is not the sine but the cosine of omega t0 plus minus kx plus theta 0. Yeah, this is not the sine, this is the cosine. Please change it in your book that this is not the sine, it is the cosine. And the oscillation acceleration of a traveling wave is equal to the first derivation of oscillation speed, which is equal to a times omega squared times the sine of theta. The theta is omega t0 plus minus kx plus theta 0. Now I'm going to discuss the example problem number 2 on page 158. We have an equation of displacement of a traveling wave, y equals minus 2 sine pi times 0.5x minus 200t minus 1/3. X and y is in centimeter and t is in second. We want to determine the direction of initial oscillation, the direction of propagation, and the initial phase angle. We know that the equation must be changed into y equals a times the sine of omega t minus kx plus theta 0. So if we still have an equation in this form, this is kx minus omega t, then we need to change the equation. Yeah, we multiply this negative sign into the brackets. So this is minus 2 sine pi times omega 0.5x. It becomes minus 2 sine 0.5 pi x minus, this becomes pi times 200 pi t minus 1/3 pi. This is the theta 0, but we have to change it into the form of y equals a times the sine of omega t minus kx plus theta 0. So this negative sign is multiplied by 0.5 pi x, so we have minus 0.5 pi x minus multiplied by minus 200 pi, we have 200 pi t. So this is the equation, and we want to find the direction of oscillation. Now we can see here that the amplitude is positive, so the direction of initial oscillation is upwards. The direction of propagation, if this k is negative, that means that the direction of propagation is from the left to the right. Yeah, so if this this k is negative, it means that it propagates from the left to the right. If this is positive, then it means that it moves from the right to the left. This is our convention. So you have to change the equation into this form. Y equals a times the sine of omega t minus kx plus theta 0. Then only then we can see the sign of the amplitude and the sign of the k. If the sign of the amplitude in this form is positive, then the initial direction of oscillation is upwards. If the sign of k is negative, then the direction of propagation is to the right. Yeah, and this is the initial phase angle, which is 1/3 pi, or pi over 3 radian. Question B, we want to find several quantities: amplitude, frequency, period, wave number, wavelength, and speed of the wave. The equation is y equals 2 sine 200 pi t minus 0.5 pi x plus 1/3 pi. And the amplitude here is 2 centimeters. To find frequency, we have to see this omega. Omega is equal to 2 pi f, and the omega itself is 200 pi. So we can calculate f to be 100 hertz. And period is, of course, 1 over frequency. It will be equal to 1 over 100 equals 0.01 second. And the wave number is given by this value, 0.5 pi centimeter to the power of -1. You don't have to include the negative sign because it only shows that the direction of propagation is to the right. And to find the wavelength, we know that k is equal to 2 pi over lambda. So lambda is 2 pi over k, where k is 0.5 pi. So the lambda, or the wavelength, is 4 centimeters. And the speed of the wave is given by the equation of v equals lambda multiplied by f. The lambda is 4 centimeters and the frequency is 100 hertz. So v, or the speed of the wave, is 400 in the unit of centimeter per second. For the next question, C, we want to find oscillation speed and oscillation acceleration given the distance and the time. Yeah. So for this, the equation is this should be pi over 3. Yeah, so you substitute t using the value given, 0.1 second, and x is substituted using the distance given. So we have this. So now we have to find the value of this theta. 200 pi times 0.1 is 20 pi. 0.5 pi, or a half pi, multiplied by 39 2/3, or 119 over 3. Yeah, plus pi over 3. And this gives the value of 119 pi over 6. So 20 pi is substituted using 120 pi over 6. And pi over 3 is equal to 2 pi over 6. So this will give us the value of 120 pi minus 119 pi is 1 pi, plus 2 pi will give us 3 pi over 6. So we have the value of 2 times the sine of 3 pi over 6 is 90 degrees. The sine of 90 degrees is 1. So the displacement at that time will be 2 centimeters. Because we know that theta is 120 pi over 6 minus 119 pi over 6 plus 2 pi over 6, it is 3 pi over 6, or 90 degrees. Then the oscillating speed is omega times a times the cosine of theta, where theta is 90 degrees. So the v is 200 pi times 2 times the cosine of 90 degrees, and that will result in 0 centimeter per second. And the oscillation acceleration is minus omega squared a times the sine of theta, and that will be minus 200 pi squared. That will be 4 times 10 to the 4 pi squared, multiplied by 2. So 8 times 10 to the 4 pi squared, multiplied by the sine of 90 degrees is equal to 1. So the acceleration is minus 8 times 10 to the power of 4 pi squared centimeter per second squared. One more problem that I would like to discuss is number 3 on page 160. We have a progressive wave travels from point S to point G, which is at a distance of 10 centimeters. And then the question is, when the source of wave has oscillated 13.6 centimeters and the equation of the progressive wave is given by this equation, we want to calculate the frequency and the period of the wave. That's question A. To find the frequency, of course, we need to change this equation first. This is the situation. We have S here and G, and the distance between the 2 points is 10 centimeters. The equation is minus 20 sine pi times 20x minus 5t. And of course, we want to change this equation into y equals a times the sine of omega t minus kx. So let's do it like this. The negative sign is multiplied by 20x, so we have minus 20 pi x, and that negative sign is multiplied by 5 minus 5t minus multiplied by pi, so we have 5 pi t minus 20 pi x. So the frequency can be calculated using omega, which is 5 pi. So 2 pi f equals 5 pi, then frequency is 2.5 hertz. And then to find the period, of course, it is 1 over frequency, which is 0.4 seconds. And to find the wavelength, we have to see that the k is 20 pi. So 20 pi is equal to 2 pi over lambda. So that lambda is 0.1 centimeters. To find the wave speed, we use the equation of v equals lambda multiplied by f. So the lambda is 0.1 centimeters and the frequency is 2.5 hertz, so we have 0.25 centimeter per second. The wave number is k, so we don't have to calculate it. K is equal to 2 pi centimeter to the power of minus 1. The direction of initial oscillation of the wave and the direction of propagation, of course, this is upwards, and the direction of propagation is to the right. And this is theta, or the phase angle. So when we want to find the phase angle at S and at G, theta S can be given when Ts is equal to 13 over 6 seconds and x equals 0. So the phase angle at S will be given by 5 pi multiplied by Ts minus 20 pi x, where x is 0 here. So we have theta S equals 65 pi over 6 radian. And the phase angle at G is when Ts equals 13 over 6 seconds and x is equal to 0.1 meter. So using this theta, 5 pi Ts minus 20 pi x, we can find that the theta or phase angle at G is 53 pi over 6 radian. Remember that this is always the t of the source of oscillation. Although we want to find theta g, but t here must be the time the source of oscillation has oscillated. Yeah, not tg, but always ts, because we have derived that the equation, so that we only use ts here. The phase angle difference between S and G, of course, it will be theta S minus theta G. Remember that the source of oscillation has oscillated before G oscillates. So theta S must be bigger than theta G. Yeah, so delta theta must be theta S minus theta g. It will be equal to 2 pi radian. The next question is about the phase at S and at G. We know that phase is equal to theta over 2 pi. So the phase at S will be equal to 65 pi over 6 divided by 2 pi. It is 65 over 12 without unit. While phase at G will be theta g divided by 2 pi, and we will have 53 over 12 with no unit. So the phase difference between S and G can be calculated using phi at S minus phi at G. It will be equal to 1. Remember that the phase at S will be greater than the phase at G because S has oscillated before G oscillates. Or we can also use this equation. Delta phi is equal to delta theta over 2 pi. So it will be equal to 1. And we want to find now the oscillating speed at S and at G. Oscillating speed is given by the derivation of displacement. Yeah, so it will be equal to omega A times the cosine of theta. So phi at S will be omega times the amplitude times the cosine of theta S. So it will be equal to 100 pi. This is 100 pi times the cosine of 65 pi over 6. That is theta S. Yeah. To find the cosine of 65 pi over 6, we can make this a small angle. 65 pi over 6 is equal to 10 pi plus 5 pi over 6. Yeah. So the cosine of 65 pi over 6 is equal to the cosine of 5 pi over 6. So in this case, we have minus 50 times the square root of 3 pi centimeter per second. The same with the oscillating speed at G. We will have omega A times the cosine of theta G, 5 pi times 20 times the cosine of 53 pi over 6, and 53 pi over 6 will be equal to 8 pi plus 5 pi over 6. So we can eliminate that 8 pi. Now we only have 5 pi times 20, 100 pi, times the cosine of 5 pi over 6. So that will give us minus 50 times the square root of 3 pi centimeter per second. And to find the oscillating acceleration at S and at G, we know that the acceleration, oscillating acceleration is dv over dt. So it will be equal to minus omega squared A times the sine of theta. So oscillating acceleration at S is minus 5 pi squared times 20 times the sine of theta S. That will give us the sine of 65 pi over 6 is equal to the sine of 5 pi over 6. Yeah, so that is a half. So the acceleration at S will be minus 250 pi squared centimeter per second squared. The same with the acceleration at G. It will be minus omega squared A times the sine of theta G. And theta G is 53 pi over 6. So that we have the value of the sine of 5 pi over 6, the same as before. Then the acceleration at G will be minus 250 pi squared centimeter per second squared. Okay, now you have to do the worked example in your book, in your physics book. Yeah, so answer the questions that I have discussed. Number 2, page 158. Number 3, page 160. And number 4, 5, 6, page 161 to 162. Please do it yourself in your physics book. For those assignments, you have to scan your work and submit it by uploading it to Scholar. Yeah, and then for next week, for Monday, March the 13th, 2020. Please do the multiple choice questions, page 165 until 167, number 6 until number 14. If we can meet at school, I will check your work next week. But if we cannot meet at school, then you have to submit your homework by uploading it to Schola next week on Monday before 10 a.m. I hope you can understand the explanation, and if you have any questions, you can contact me at these numbers below. You can WhatsApp or Line, or you can see my Instagram ID here. If you don't understand something, then you can contact me and ask me questions. Thank you. I hope you can understand my explanation.